So now we're moving on to two-dimensional motion, and we just have to think about, you have to learn some vector notation and some vector concepts. So rather than the displacement just being left, right, or up or down, now we have to think about like, well, what if it is up and to the right? Or what if it is straight up? It could still be straight up. But what if the path that it's moving on, right, is not just left, right, but it's like up and down? And then we still think about the displacement vector as pointing in a direction, right? That would be the displacement from the start to the end of the motion. And so what we want to do is think about, we need to learn an important skill, and this first important skill is called vector decomposition. So if I have a vector can point in any direction now, not just left or right or up or down, it actually can point in any direction, but we're going to reuse a lot of the stuff we did in one-dimensional motion. Okay, and so what we're usually going to do is we're going to, let's say we have a vector like this that's pointing up and to the right. We're going to split it into the x and y components. So we think of two-dimensional motion as simply two one-dimensional motions. Okay, and so the whole idea in the vector decomposition is that you're going to take an arrow, like a vector that points in a direction, and you're going to split it, so let's say I have a vector like this, and I'm going to split it into the x and y, and the key thing you want to remember is you're going to draw an arrow, okay, that is parallel to the left or right axis, and then one that is then vertical. And you need to do this tail to head method. That means the arrow, because remember vectors, even if we do 1D vectors, it's important that we know the direction of that vector. So this thing's pointing up and to the right, so you want to draw an arrow to the right and then an upward arrow. This is a really important skill. You're going to use this the rest of AP Physics 1, so you got to get this down correctly for vector decomposition. Now, in general, you maybe haven't looked at this somewhere, but if you have, let's say this is A, this is B, and then this is C, you would know that the sine of theta this is a right, because we form a right triangle here. The sine of theta would be, this angle here would be opposite over hypotenuse, C over A, and cosine of theta would be the adjacent over hypotenuse, which would be B over A. And notice that if I solved for C, you would get A sine theta is equal to C, so this is A sine theta. And then if you move the A over here, you get A cosine theta is equal to B. So this is A cosine theta. And so that's what you see in this picture. If the magnitude of the arrow, the length of the arrow is pointing in that direction, has a length V, then the composition is going to V cosine theta, the adjacent side, and then the hypotenuse times sine theta would be the opposite side. So we're going to do that a lot. So let's go through some examples of vector decomposition. So given that, especially that let's say the x and the y axis might not always be horizontal and vertical, but you still want to be able to draw it. So we're going to draw the decomposed vectors here. You're going to draw a vector like this way, and then draw a vector perpendicular to here like this. Okay, that's one way to do it. Another way to do it is you could draw, and you're going to make a right triangle here. Another way to do it was to draw an arrow upward parallel to here, and then another vector, again, parallel to the x-axis here. So the whole idea is, where do I stop, is I'm trying to make a right triangle. So this vector here is parallel to the y-axis. This vector here is parallel to the x-axis. And again, notice the arrows following tip to tail. It's like here I was going up and to the right. Now I got to go this way and then this way to get to that same location. Let's say it's rotated this way. How would we decompose the vector? Well, you would say, okay, I want to draw a vector maybe in the y direction like this and stop about there, because the next vector needs to be parallel to the x-axis and make a right triangle. Keep in mind, you got to make the right triangle, right angle right here, okay? So you don't want to do this. Here's some mistakes you can make. It's not going to be like this and then this. This is not making a right angle anymore. Even though these two components would add to it, it's not making a right angle. You got to make that right angle right there at that corner. It's got to just only go and make a 90-degree turn right there, okay? And so that's how you draw the decomposed vector. We do that a lot. All the units, in some ways, you're usually going to do some kind of decomposition. So now let's decompose it. This is horizontal decomposition, but let's decompose it here. Again, if you have an angle, then what you want to do is you just want to draw this, and then this would be our vertical axis, and then this hypotenuse is 12, so this would be 12 cosine 60 degrees, because it's adjacent, and this is the opposite side. This would be 12 sine 60 degrees, and that would be the decomposition. I usually do the decomposition along the angle. So like you could have decomposed it this way. The problem with decomposing it this way is you don't have this angle, so it's not really a useful decomposition if you do it that way. Okay, but it would still work. So here's another decomposition. We're going to go left here, and then up into a point where now I want to do an up and down, because then you got to make that right angle right here, right? So it's left and then down. Those arrows are super important because they indicate whether that vector in that direction is positive or negative, right? And then this is the adjacent side. This side is 20, so this is 20 cosine 30 degrees. This is the opposite side of the angle, so this is 20 sine 30 degrees, just like your SOHCAHTOA stuff you did in geometry. Okay, and then let's look at magnitude. Sometimes you have the components, right? Like this is what we just talked about, but you want to find the magnitude and the angle. So sometimes you have the x and the y components, and you got to make the angle, and like these two guys, and you want to figure that out. And you use, if you know the x and y, you know tangent of theta in this picture would be vy, would be opposite, because it's a right triangle, opposite over adjacent. And if you wanted to find the length of the hypotenuse, you would do Pythagorean theorem. Okay, so let's take a look at some examples here. So find the magnitude and angle of the following vector based on the x and y component. So this is here where we have like a x component, a horizontal component, vertical component. You can redraw it where this side is 10 and then make that right triangle again. And then this side would be 5. Okay, and then the hypotenuse would be this part, which you would say is the square root of 10 squared plus 5 squared. And then if you wanted to know, say, this angle, you would say, oh, tangent of that angle is 5 over 10. So theta is, you would just use your calculator, inverse tangent of 5 over 10, like that. Okay, let's say you had something like this. You had a 3 to the left and 5. And again, you could draw a right triangle. 3, this side is 5. And then if you wanted the hypotenuse length, the magnitude here, you would do the square root of 5 squared plus 3 squared. And again, it kind of depends on which angle you want, which one. But if you wanted this angle, you would say tangent of that angle would be opposite over hypotenuse, 5 divided by 3. So theta would be inverse tangent of 5 over 3, right? And so that's how you could solve something like that. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.